Good afternoon. This is Tapan Bagchi. I have a series of lectures prepared for you. It's on the topic of Six Sigma, which is right at the frontier of quality management these days. I have actually 3 sessions. The material covers 2 sessions, but I'm going to stretch it a little bit to give you a little bit more time to understand what is going on here. So let's start with the very first lecture, which is going to be outlined by this. The lecture objectives are an overview of quality management. That's what I'll try to do. Then I'll discuss total quality management. This is a special approach to managing all activities that relate to quality. The third thing I'll do is I'll discuss to some degree specifications which are a way to convey customer requirements, and then something called quality costs. That also would be discussed right here. Then I'll briefly outline some of the tools. These are called TQM tools. These have been popularized by the Japanese and they are now used worldwide. And I'll discuss the basic tools with you and you'll see their role in controlling quality. And then of course I'll give you a little glimpse of what benchmarking is, and we'll take a look at ISO 9000 very briefly. And the same thing I'll be doing with service quality management. Then of course we'll round it off toward the end of the third session of this series, which will discuss Six Sigma quality. So let's get on with this. Quality has been defined variously. If you see the definitions of quality, some people call it perfection. Some people who are interested in getting delivery of goods and services, they'd like to see quality implying fast delivery. Then of course we've got providing good and usable product. That's actually one of the requirements. That's how sometimes quality is defined. Fitness for use. This is the phrase that was used by Joseph Juran. He said this is the phrase we should be using when we discuss quality. Some other people thought elimination of waste, that's something that's linked to good quality. So that will be there. Then consistency or variance reduction. That also turned out to be one of the objectives of perfect quality. Then of course, if you have good quality, you'll do it right the first time. That's like one of the objectives for some people. Then delighting or pleasing customers, particularly when competition becomes strong. Then at that point, people who select out your business out of the large number of choices they have, they are the people who would like to be delighted or they'd like to be pleased when they have a business transaction with you. In fact, this totality can be conveyed by this phrase called total customer service and satisfaction. And of course, alongside go compliance with policies and procedures. These are the different indications of there being quality. That's what is meant when we discuss quality today. Now, what exactly is Six Sigma? Because the theme of this particular lecture is Six Sigma. The full series addresses various aspects of Six Sigma. Let's take a look at what Six Sigma really is. It's a business process improvement approach. The focus of Six Sigma is on improvement and the attainment of a final quality level or defect level, which is in parts per million. And that's a pretty good level of quality. If you look at the products and services around us, you'd probably agree that if I can deliver defect levels at a level when it's only 3 or 4 parts per million, that's pretty good quality. That's the objective of Six Sigma. That's the ultimate objective of Six Sigma. What does Six Sigma really try to do? It tries to eliminate causes of defects and any errors that there might be in manufacturing and service processes. That's something Six Sigma tries to do. It focuses on the output and those particular outputs that are critical to customers. And also Six Sigma tries to look for a clear financial return for the organization that's delivering this. And as I already mentioned, the objective of Six Sigma is to reach a defect level that's only in parts per million. Who started all this? It was one company that was almost ready to go under. They had lost their market share from being 90% to 10%. And this was the Motorola company that provided these handsets. They came way before your cell phones and mobile phones. These were handheld telecommunication sets. There was a time when Motorola had the monopoly in this business. But there was a time again when their quality slipped, and as a result, the Japanese and many other suppliers, they started providing the same product. And the quality was much better with them, these competitive companies, and Motorola started to lose its market share, and it came down to the point when it had only 10% of the market share that it originally had at 90% level. And the company that actually popularized Six Sigma was GE, General Electric. And there's one person, if I do not mention his name, the story will not be complete. That is Jack Welch. He was the CEO of General Electric, and he saw the results at Motorola, and he decided this was the way for GE also to go. And of course, many other companies, they followed the same route. So the company that actually started this was Motorola. They started the Six Sigma movement, the movement toward excellence, and the company that popularized the practices and processes, it was General Electric. Let's take a look at the march of quality and how the movement in quality assurance, how it has evolved over years. Back in around 1930, which is the time when a long time back, people produced items that were generally one of a kind. Like you built a particular building, for example, like Taj Mahal is one of the examples, or there were many pieces of art that were produced one of a kind. There, of course, quality assurance was done by inspection. Basically, it was either the craftsman himself, he did the inspection, or the receiver, the gentleman who was actually paying for this artifact, he would be doing the inspection. And inspection turned out to be the only means to control quality at that stage. And that was fine if your production rate was quite small and you could inspect each of the items. If you could do that, there was generally no problem. But the moment it was a matter of mass production, you had to produce the same sort of thing in multiples. Then you could not really inspect one, then the next, and so on and so forth. If you're doing that, forever you'll be doing only inspection. At that point, people realized what we need to do is, we need to worry about the process also. So they looked at, for example, I'm going to draw a little box here, which is your process. And you have the output, which is really what the customer is interested in. And the process itself is basically impacted by many different factors. Alongside these factors that are probably control factors, you control them, there are noise factors also. Noise factors are generally not in your control. The result is this, that instead of getting one single output point, you'll end up with a distribution. And that would look like this, which will really show a variation. It turns out in such a case that many times what is acceptable to the customer is not what is delivered by the process. So if I draw these two limits and I call them upper spec limit and lower spec limit, I notice that there are parts of production, there are fractions of production that are not acceptable to the customer. Now I cannot sell this stuff, and I cannot sell this stuff. And what I can really sell is what is in the middle. This is the part I can sell. Now a couple of things we have to remember. This variation, the variation that you see here, this variation is being caused because not all these factors are in your control. They do not stay exactly where you set them. They tend to change a little bit this way or that way. That actually is suggesting that the process itself is causing some variation. So is there some way by which I could control the process and I could make sure most of my production is in this range, which is the acceptable range? Can I do that? That was the question. And there was a gentleman, and he worked for the Western Electric Company. His name was Walter Schuhart. Schuhart came up with the idea that if I observe the output and I collect some data from there, and depending on what I want to adjust, if I can utilize that data to come back and control these factors, I'll be controlling the process, and thereby I'll be controlling the output. And it's very possible if I do it well, my production would all turn out to be acceptable, and my production would be sort of like this, which is okay, because I could stay in business with this sort of output. What am I doing? I'm collecting some data. Then I look at some aspects of that data. which is going to be useful for me. So I take some aspect of that data and I basically do this statistically. I look at the aspects of the data that really have some value to me. Then I use that feedback and I utilize that feedback to try to control these process variables. So I'll be sometimes controlling this one, sometimes I'll be controlling this one, sometimes I'll be controlling that one. What I'm doing is I'm using data to produce the feedback, and the control action takes place based on the deviation from where you expect the output to be. And this deviation, of course, it is detected statistically by using what we call control limits. This whole approach is called SPC. SPC stands for Statistical Process Control. And as you notice here, on this chart that I have here, SPC turns out to be right here. And this is the notation basically. This actually tells you that I'm not just inspecting the product, but I'm looking at ways to control the process. This was one way. Of course, for a long time, people then started using SPC, and that is what was done in the 1940s. In the 50s also, people were using SPC. But at that point, a question came up as to how do you know, if you go back to the figure here, how do you know whether I should control factor A, or should I control factor B, or should I control factor C? This was not known at that point. Was there a method, or could we devise a method by which we could really say you can leave A alone because A really does not have much impact on Y. But yes, you have to control B and you have to keep an eye on C also, because these two are factors that have an impact on Y. So here what I'm talking about is I'm discussing basically, I'm mentioning a cause and effect relationship. These are the causes and this is the effect there. What basically we would like to do is, we would like to find out first of all which of these control factors really has an impact on Y, and which has a strong impact, which factor, and which factor has not such a strong impact. This can be found a technique that is called DOE, design of experiments. So then SPC moved up to DOE. The job of this DOE, who will be doing this DOE? SPC could be done by production people, but DOE is more of a research nature. DOE is to be done by R&D people, research and development people. Their job is going to be to discover knowledge, really to find this dependency between the causes and the effect. This is to be done by R&D people. They are the ones who utilize this technique of DOE, and you'll see right about the middle of the page, this phrase DOE is written, that is design of experiments. It's a special way to try to improve a process. I'll be discussing this as we go deep into this. I'll be discussing various things about DOE, that I'll do that. And in the lectures itself, in the third part that I have here, I'll be giving you some glimpse of how DOE is actually utilized. Now there was somebody, his name was Jenichi Taguchi in Japan. He utilized DOE in a very clever way. He said he found out that 2/3 of the problems that actually was found in the field with bicycles, cars, plastic products, watches, you name it, 2/3 of the problems could be traced to what we call the design of the process or the design of the product. So design then became a major culprit. The focus then shifted from that being on the process. People started to worry about optimizing the design of the product or the design of the process. These two then became the target. In fact, what was done was what I described to you just a few minutes earlier. They tried to find out which of the factors, which of the design factors, A, B, C, etc., which of these really were the influencing factor as far as the response of that product was concerned. And the same thing will go for the process also. I have other factors, little a, little b, little c, little d, and so on. Again, the question was, which of these really were the critical ones? This could be found if I did DOE. So it turned out that in design development, DOE became a big tool. DOE or design of experiments became a big tool to try to come up with good designs. This was done the first time by this gentleman, his name is Jenichi Taguchi. Taguchi was the gentleman who, for the first time, he came up with this idea of trying to impact design. And he came up with some very special designs. One of the kinds of designs he came up with is called robust design. I'll give you an example of robust design. As we go into the thing, you'll find these are very special designs and they hold on to their performance even if the environment becomes hostile. Even if there is dust, there is humidity, there is high temperature, low temperature, whatever, vibration and so on and so forth, or component qualities are not that good, even then a robust design will retain its performance. That's something that's a very special type of design, and Taguchi was the father of that kind of creation. Of course, you'll have all these techniques, but we all know you can put things together, you can put people, machines, materials, all those things together. But unless you have a proper management system, things really will not work very well. So there, people again shifted their gears and they figured out what we needed to do was have appropriate quality management systems. One of the quality management systems that is actually pretty common, most of you have heard of it, is called TQM, Total Quality Management. And that is something I'll be talking about as we go through this particular lecture. I'll be discussing TQM. That's what I'll be doing. And there are, of course, systems which are not as comprehensive as TQM, but they are also pretty decent systems. And one example is ISO 9000. It's also a quality management system. So neither TQM nor ISO 9000 does directly control quality. It does not do that. But it provides you with a framework. It provides you with a management system. And if you go through the process of TQM or you go through the steps of ISO 9000, you'll end up with good products, good output, high level of customer satisfaction and high profits also. This is something that invariably comes along if you use a good management system. And of course, other systems are also there, for example, QS 9000. Then of course, you've got something called ISO 14000 with a slightly different agenda. So I'll be discussing these as we go along, but do remember these all different things, they are different, they are distinct quality management systems. That's what these things are. These are quality management systems. These are systems within which we operate and we try to get good performance. And they cover various things. It turned out in the 60s and 70s and 80s, many people they tried to go the TQM route. Many people in the 80s, many companies, they tried to get the ISO 9000 certification. And many automotive part suppliers, they went for QS 9000 as an example. So various systems were tried on the shop floor. In the management of quality, many different systems were tried. But it turned out in many cases, this really did not impact the bottom line of the company. That means the profits of the company. It did not really impact that much. And there was a reason. The reason was most of this was sold, most of this was presented in the form of philosophies. They were really not given as tools that would directly impact profits. It was not presented that way. The agenda actually was something different. What ended up happening was, people then started looking for ways to basically leave TQM aside. I know about companies that issued official memos first to say that yes, people should go through the TQM training. Then after some time, after a couple of years, they said, we're going to stop all these TQM meetings because they're just a waste of time. We do not see results impacting the bottom line. Then of course, a big problem came along. People then started saying, how do we change things then? How do we really impact that bottom line? That is when this Six Sigma movement came along. And you will see as we go into this, Six Sigma is a procedure that really has an impact on the bottom line, which is dollars. Because Six Sigma is conceived, planned, implemented, executed in a special way. You cannot start a Six Sigma project unless you can foretell, unless you can project the impact of that particular project on the bottom line. Unless you are able to do that justification, you are not supposed to really start a Six Sigma project. And when the project is complete, you are supposed to do an audit and figure out, really did I get those savings? This is something that is a must for Six Sigma projects. So this is now quite different from the TQM approach. In TQM, we essentially talked about good practices. It's like for good health, you have to take a walk in the morning. You have to avoid cholesterol. You have to do a bunch of things. But really, as far as our normal life is concerned, we really do not come back and make a measurement of our blood cholesterol, for example, after taking a walk. We do it on faith. And TQM was supposed to be, it was actually packaged and presented that way. If you do certain things, it will be good for the company, it will impact quality and so on. But people were not able to see those results at the bottom line. This changed the moment people moved on to Six Sigma, because Six Sigma was launched project by project by project. And I'll give you the framework whereby I'll show you how you pick the project, how you decide what project to work on, how you work out the justification, how you execute the project, and how you come back and verify that yes indeed I've got those materials, those results materialized. How I do that. This is done again for Six Sigma with a special framework, and that framework is called DMAIC. D-M-A-I-C. Define, measure, analyze, improve, and control. This is a special framework that is used in every Six Sigma project. And this is not an easy process. The DMAIC process is not an easy process. I've done about a dozen DMAIC projects, and I'll tell you it's not very easy. First of all, to retain the discipline, make sure that you can get the justification done, justification worked out in real rupees and paise. This is what you have to do before you start the project. Once you've done that, you have to define really what is critical for the customer. Then you have to go into this measurement business. Then you have to do some analysis, and you might be using some TQM tools like the cause and effect diagram, the fishbone diagram, for example. You do that, you do flow charting, you do mapping of the process and so on. Then you identify factors with which you will be playing. Basically, that's when you enter kind of the R&D shop. From being in quality management, you enter the R&D shop and you do some actual experiments. And this is how improvements are sought. Improvements are sought in the Six Sigma framework by going to this step which is called I. I is improvement. And I utilizes DOE. I utilizes what we called earlier design of experiments. DOE is the tool at the ith stage. Once you identified the right settings for the parameters, then of course you set them at their optimum values and you make sure that you control them. And that could be done by utilizing control charts or SPC. Once you've settled down basically what the best settings are going to be for these processes. And that's the ultimate. So if we come back to the slide here again, you see the march. Inspection basically is the point when I'm doing nothing except just checking if the product is acceptable or it is not acceptable. If I move up from that, this is just fine when I've got a few parts to produce, then this is fine. The moment we move up from there to what we call SPC, I shift my focus to the process. I try to do statistical process control. To try to find factors that are important in controlling the process, I may have to use a technique called DOE, design of experiments. And if I have to produce good designs of parts, products or the process, I'll be using the Taguchi methods. Then of course, the next thing is to move up to a good management system, and for that we may utilize TQM or we may utilize ISO 9000. These are a couple of systems that work pretty well. But exactly only having those systems will not produce the profits. And that is done by this latest system called the Six Sigma way to manage your quality. And Six Sigma is the focus of this series of lectures, and we'll be visiting various parts of it. While we are doing that, of course, we'll be looking at inspection, we'll be looking at SPC, we'll be looking at all these different things. Then only we'll be moving up to there. So again, to rehash what we've done so far, the very first point was skilled craftsmanship. This was fine in the Middle Ages when the product was basically one of a kind. Then when Industrial Revolution came along, inspection, the volume of inspection went up, and the problem was there were many items to be inspected. At that time, different quality departments were set up. They were separated from production departments, but their job was basically focused on inspection only, nothing more. Then came along the 20th century when people realized, particularly in the Bell Telephone Company, that what we needed was something that was suitable for mass manufacture. And there people devised this method of SPC, statistical process control. And that continued till World War II. About that time, people started looking a little deeper peep into the process itself, and they started to experiment with products. They started to experiment with product designs. They started to experiment with the process, and they utilized this technique called DOE, design of experiments. And of course, at this time, if you remember, the Japanese had nothing standing above ground because most of the factories had been smashed up, and they wanted to come back. Their business, it's a small country, and the only way they can survive is to get into trading. That means produce something that other countries probably do not have, but they are the consumers of those products. And there, basically, quality movement got a big push. It turned out that they hired Americans. They hired Edward Deming and they hired Joseph Juran. They became trainers of the Japanese engineers and production managers. And there the Japanese started to, first they learned what Deming and Juran were telling them, and then they started to innovate also with new methods. If you look at the parallel of it, the way things went on in the US, for a long time US had monopoly basically. US was the only country where most of the production machinery survived. There were no bomb followings on New York, there were no bomb followings on Ohio and so on and so forth. So most of those factories survived. Detroit has no bombing, and therefore of course cars could be produced, machines could be produced, and these could be sold the world over. So the market was there waiting for them. So whatever, and because of their edge in technology and surviving technology, whatever the Americans could produce, that could be sold. So really there was no particular need. Any country would have done the same thing. If I'm able to sell whatever I produce, what is the need for me to improve? And that was the reason, unfortunately, the Americans continued to operate that way. Even in the 1950s and 60s, that was the time when other countries became active. They also started producing good cars, good products and everything else. This was actually a big problem. And it turned out, in that case, something had to be done. And they started looking into other means to try to improve quality. And that's when the Americans also, they started to bring in awards and rewards and so on and so forth. And they also started to see what is it that the Japanese were doing or the Germans were doing, and they started to do this. This is the time when the quality management system overall, it was also criticized a lot, and many people, they were disappointed with the quality systems that were in place in those days. Then of course came the time when management systems were put in place, things like TQM as an example. And quality was required not only for production, quality was also required for services, for the delivery of services. And many of these organizations that were engaged in services, they also started to look at TQM tools and so on and so forth, and they started to embrace them, they started to use them. That was the time, because of competition, some companies were almost on the brink of going out of business. One of them was Motorola. And Motorola is the one that actually took the initiative, and they thought they had to raise their level of quality to the point when the level of defects came down to the level of parts per million. And that's where they took their own production and they regained a lot of business. If they hadn't done that, they would be out of business. Many companies in the world, they've gone out of business. But very fortunately, Motorola people recognize this, and they use this very powerful method called Six Sigma. Six Sigma started there, and Six Sigma was carried further into a very mature process by GE, and in particular by the chairman of GE, that was Jack Welch. He made sure that his vice presidents, they picked up the black belt methods and so on and so forth. He himself got trained in statistics and DOE and so on, and he became an example. He became a personal example that, look, I can also learn, I can also conduct these Six Sigma projects, and I can also really make an impact on the bottom line. That really was the goal. If you look at quality management, the total process of quality management, it has gone through a tremendous amount of maturing. How has this happened? In the old days, the only way to manage quality was quality control, which is by inspection. Quality control was the only way to try to control quality. Then of course, people became a bit more proactive, and they got into what is called quality assurance, which is like, look at the parts before you put them into your system, before you do the assembly. Look at the quality of parts that you have. Do more extensive inspection do sampling and so on and so forth, do those things. Then of course, people realized that because there were so many activities to be managed in the delivery of quality, I had to have a planning system in place. And such planning systems are brought out in systems like quality management systems, such as ISO 9000. They give you a formal stage, in fact. In the total process of ISO 9000 commissioning, you go through a stage, and at some point in time, you say, I'm going to be doing planning of quality. I'm going to really figure out all the different steps that I've got to go through. For example, I'll have to train my people, I have to calibrate my instruments, I have to check my suppliers, I have to check my process, I have to make sure I do some trials. All those things have to go through in a very systematic way. And this can be done only if you've got a good plan. So that's the highest level of maturity you have. And once you've got a plan, at that point you realize you need some special tools, special training and so on and so forth. That also would be coming as you go along, as it's indicated by your process plan. Let's take a look at a couple of things. For example, let's look at the distinction between TQM and Six Sigma. This probably has been the biggest revolution in the world of quality management. In the old days, like I said, in the 40s and 50s and 60s, TQM was the way to go. In fact, in the 60s and 70s, most companies, they did a lot of TQM training. They trained people on the 7 tools and so on and so forth. They set up quality circles. They do a number of other things that would be consistent with the TQM philosophy, but they stayed at the philosophy level. In fact, it turned out TQM says the following things. It says you should empower the worker so that he can discover problems and he can fix the problems themselves. He should also, TQM also says the focus really should be the workplace, because that's where quality can be impacted in the maximum, to the maximum extent. If you're doing TQM, you'll be using some simple tools of improvement, like the 7 tools of improvement. I'll give you some examples of those. But unfortunately, TQM does not really worry about the dollars and cents or rupees and paise. TQM has nothing to do with financial accountability. If you do TQM, you're doing it because of faith that you have in this quality management system. Contrast that now with Six Sigma. Six Sigma is led by business leaders or champions, not only by workers. Basically, Six Sigma is launched project by project, and each project is approved at the highest level by people who understand what is going on. They know quality, they also understand basically finances and so on, they understand rupees and paise, and they are the people who basically own the process owners. They become owners of this thing. Then of course, you've got cross-functional projects. Almost no problem can be solved by one department. That is just not possible. Now what we have to do is we have to really bring people. They'll come from a variety of different places. They'll come from production, they may come from purchase, they may come from accounting, and so on and so forth. And they bring their skills, and you have to put it all together in a manner that is cross-functional. Then you get best results. And of course, one thing Six Sigma does is, if you look at TQM tools and you contrast them with DOE tools or Six Sigma tools, there's a vast difference in the statistical capability, the statistical sophistication of Six Sigma tools versus those tools that are used by, for example, the Pareto chart and the histograms and so on, which are used by TQM people. And of course, one thing that really Six Sigma requires that is distinct from total quality management is it requires verifiable return on investment. If I'm spending some money to try to make sure that I get an improvement, I should measure the returns in rupees and paise. I should at some point quantify the returns, and that is a must with Six Sigma projects. Each Six Sigma project must impact the bottom line. You cannot escape that. So the distinctions again, TQM is a philosophy and Six Sigma has its focus on business, and in particular the bottom line. Bottom line is a profit line. Let's take a look at some of the tools. You'll probably recognize this tool. This is the cause and effect diagram, which is also called the fishbone diagram. It illustrates the comparison, the cause and effect relationship between causes, which are on the left, and the effect, which is on the right. And this tool, of course, is a great tool to try to do brainstorm. If you've got a situation when one has a lot of debate about what might have gone wrong, use the cause and effect diagram. So it's a very effective tool. So that's something that's like a typical tool that is used in TQM, Total Quality Management. Six Sigma is quite different. Six Sigma uses a framework, and like I mentioned earlier, it uses a particular framework called DMAIC, D-M-A-I-C. What does this stand for? It has special roles that are split out between these different steps. For example, D is define. Define what is critical to the customer and define the deviation that he is expecting, that he is experiencing. Then M is the step where you measure the deviation. You measure what is expected and what I am getting actually. So I have defined the issue and then I made a measurement about it. So I am moving along this Six Sigma step. The third step is you analyze. You try to get in, you try to utilize some of the TQM tools and you try to find out what is the extent of this problem. Is this something that recurs every day? In every piece there is a problem like this. Anything that I produce, it has a problem like that. Maybe the pens, if I look at the tips of the felt pens, maybe those tips are not good enough or something like that. Is that really happening to one or two pens or to all the pens that I produce and stuff like that. This is when you get into analysis. At this stage, you could also draw a cause and effect diagram and you could do that. That is the analysis stage. Once I've analyzed and I've figured out that certain factors might be causing the problem, you then get into problem solving and you get into this improvement. And the big tool that is used with improvement is DOE, design of experiments, which I mentioned. If you go back to my slide here, I mentioned here DOE, design of experiments. That is a very, very powerful method. What it really does is, it looks at a process. It looks at a process which might look pretty complicated. This process looks pretty complicated. There are so many factors influencing this. And if the expert says try to control all the factors, it won't be very efficient. Therefore, I need this technique called DOE. I need this technique called DOE to tell me which of these factors really is the culprit. Which is the factor that has got the strongest effect, and is there a factor that I can completely ignore when I am trying to really control the process. If I do it this way, I can do divide and rule, and if I do that, I can start with a poor process, a bad process like the black line there. I can get to this green process which has got most of the production well within the specification limits. This is the advantage of doing it by following the DMAIC procedure. So let's get back to the slide here again. Notice here, I defined what the issue was, I made some measurements, then I did some analysis, I might have used the cause and effect diagram, then I do improvement when I am using DOE and perhaps some other statistical methods, then I do control, which is like when I find the optimum setting for those different variables and I start controlling the process to be there. And one easy way to do that is to apply SPC at the input stage also. If I do this, of course, I may actually have to utilize some other statistical tools also. The result is generally that you reach the defect level of parts per million. I should mention something here. Six Sigma does not really require all processes to be driven to the Six Sigma level, because there are processes existing right now that are far better than Six Sigma. My digital watch, this has a performance that is far better than Six Sigma. It loses a microsecond or a nanosecond in some God knows how many years. So this is giving me a performance that is far better than Six Sigma. So there already are many processes that are far better than Six Sigma. And of course, you've got many other processes, like for example, filling a certain amount of water in a bottle. That's probably at the percent level of defect. Now, if this distilled water was expensive, I'll have to control the amount of water that goes into a bottle. And there probably being off by 2 or 3 or 4% would not be very desirable. In that case, I'd like to reduce that to a fraction of a percent. Still, it's not necessary that I fill water in a bottle at parts per million level. It's not necessary. It all depends on the application. So when people say, in my company, can I use Six Sigma? I say yes. As long as you're getting an improvement, a measurable improvement, and that has an impact on your bottom line, you're using the Six Sigma philosophy. And lo and behold, someday you will be best in town and best in the country and perhaps best globally. And most of the business will come to your water bottle because of the purity of the water there, because of the quantity that is so there, and the seal that you provide and so on. People will be preferring this to some other bottle that is there. So this is something we got to keep in mind. Six Sigma does not really mean that everybody has to go to this parts per million level. That is not necessary. How do I do that? Again, if you look at the top line there, that's an existing business process. It shows you a flow chart. In fact, if we go from the left to the right, it shows you suppliers are supplying some parts or materials or labor, and those constitute the input. Then I've got the conversion process, which is the manufacturing or service process. I produce some outputs and those are sold to customers. I take this process and I apply the Six Sigma or the DMAC framework on it. What are the results? If I take this process and I apply this, the results are higher quality, higher productivity, lower cost, and obviously higher profitability. This is the outcome. I take my process, I put it through DMAC, and I end up with this. If you've conceived your project correctly, if you've conceived your Six Sigma project correctly, if you've defined the charter, if you've defined the scope, if you got it detailed into work breakdown structure, if you have assigned the task to the right people, if they're using the right tools, you will end up with the bottom line impact. There's just no escape, because all this is based on science. You can't argue with science. This has been thought through, this has been looked at by a number of people. They've looked at these different techniques in isolated situations. And what they found is, yes, the tools are very effective. They just have to be sequenced correctly and they have to be applied exactly when they are needed. That's what needs to be done. Who does Six Sigma work for? Six Sigma now is a business process. Who does it work for? Who does it benefit? Clearly customers, they end up with a higher level of satisfaction. Plant managers, because they have less waste. If you look at, if I go back to my diagram again, my little favorite diagram on the screen here, this red part is waste. And this red part is also waste because I cannot sell those parts. I cannot sell these parts or these parts. And if I'm doing assembly and my parts are coming out like this, I cannot really put them into the assembly shop because many of those parts will not fit the next stage and therefore it's going to be a waste. So this is a loss and this is also a loss. What Six Sigma does, it helps you reducing this and also reducing this because the total curve shrinks, because the process that was wide like this, it picks up a lower and lower and lower variance and you have a smaller variability, and that is wholly within your requirements. That is one of the objectives of Six Sigma. So plant managers, they end up benefiting like that. Human resource managers, it has been seen that if you use the DMAC procedure, you can reduce the cycle time for hiring people. You are more focused, you ask the right questions, you are pointing things that really matter. So that is something that is done quite easily. So that's something that has to be kept in mind. Then of course sales managers, they improve a lot because they end up with better forecasts. They also have better pricing strategies, and pricing variation also reduces if they are using the Six Sigma approach. And almost anyone who wants to better understand customer requirements, as an example, and he wants to tailor their service in a way that's going to delight the customer, it's really good if he utilizes, it's really going to be useful if he utilizes the DMAC framework. That is like one of the reasons why DMAC has become so important. Something we have to remember, of course, all these things, they were not conceived like one night somebody went to bed and he had some dreams and he had all these flashes and so on and came up with all these different ideas. Because there are many good ideas there, whole lot of good ideas there. And these ideas, they've been compiled over decades. And they started with what we call Deming, the father of modern quality movement. And he came up with this PDCA operating practice, and also he had a lot to tell to management. And as I get into TQM, I'll tell you exactly what he had to say to management. Then came Juran, another guru of quality, and he also talked about management practices, and he also talked about something very important called the cost of quality. Juran also highlighted the value of training. This, he said, was something that many companies miss out on. Then of course there was this gentleman, his name was Armand Feigenbaum. Feigenbaum actually was the gentleman who conceived this idea of TQM. He could really see that TQM was not something that could be done by one person or one group or one department. A lot of people had to be involved. They all had a distinct function, and they had to make sure that those functions, they were all carried out the way, in a manner that was like a people working together. And the totality of all this was probably something that could not be substituted by no matter how much effort one particular department or division made. It had to be a total involvement of basically everybody in the company. Then of course you had Kaoru Ishikawa, a Japanese. He came up with the idea of quality circles, which involves people, and people are involved in a voluntary manner. And Ishikawa also provided us what became later known as TQM Tools, the 7 tools of quality control, quality assurance, quality management. That also was a gift given by Ishikawa. Then of course there was this gentleman, Phil Crosby. Phil Crosby utilized the idea that was given by Juran when he talked about cost of quality. So Phil Crosby utilized the idea of cost of quality, and he said ultimately that quality is free because you don't have any defects anymore. And the defects that you've done away with, the loss that you had because you had defects, the rework and the scrap and bunch of other stuff that actually happens in the customer shop, if you're able to afford all that, then the effort that you put into delivering good quality, that is really free because you don't have these losses anymore. Then of course the last gentleman in the string, his name is Jenichi Taguchi, and I mentioned he gave us a couple of things. One big thing he gave was the idea of robust design. The other thing that Taguchi also gave us was this idea of quality loss function. That means as you go away from the target, I'm going to give you some examples of this, and I'll give you some real life example. How did people realize that yes, it made sense to go this way? It made sense to go the Taguchi philosophy way. That is something that will be done. Now, what about consequences of poor quality? Suppose I do not have good quality. What are the consequences? Let's take a look at it. Let's take a look at the very first one, and I put that in red ink. The product fails. My God. In the hands of the customer, when the customer is trying to utilize that product, the product is not functioning the way it was expected to be. And that will really directly lead to loss of business. The product does not meet requirement. That's also a result very clearly of poor quality. I purchase a product, no matter what I purchase. I might be purchasing a pen, I might be purchasing a mouse, I might be purchasing a PC, I might be purchasing a piece of writing paper, any of these things. There's a requirement. There's a purpose for my buying these things. If those requirements are not met, what good is this? So if you have poor quality, that actually means some of those requirements are not being met by the product or the service. For example, haircut. I have a certain particular requirement. I want to look in a certain way. I want to look like somebody perhaps, or I have a peculiar style, and I want it to be that way. I want my mustache trimmed in a certain way. If I do not get that, if I end up with a, kind of a mustache that really does not suit me, will I be happy? I will not be. So there are requirements all along, and I have to be mindful of these requirements. If I am thinking of quality, I have to be mindful of those requirements. If not, I am really moving toward what we call poor quality. Then of course, loss of business. That's something very, very important. I have to remember that I will definitely have loss of business if I do not really worry about quality. I will definitely have loss of business. Liability is of course a big business for people who are in the insurance business. It turns out liability is such an issue. It could be with, the Tylenol story, the Firestone tire story, and a number of other stories where people were taken to the court because quality was not there. And it really had some pretty bad impact. People probably lost their lives and so on and so forth. So liability is something that also goes hand in hand with poor quality. Then of course productivity loss. Again, if you go back to my little favorite diagram here, I cannot sell the stuff that is on this side. I cannot also sell stuff that is on this side. But suppose a worker produced only this stuff or this stuff. Is it really being productive for me? It's only those workers who are producing the green stuff. They are the ones who are productive in my eyes. And it's worth paying them something. But the guy who is producing stuff that is landing up in the off-spec area here or the off-spec area here, they're really no good for me. So as far as I'm concerned, their productivity is zero. So I should not really, at this point I should emphasize, I should not measure quantity only. I should really see quantity, yes, but let's make sure every item that I count has quality. Unless I have quality as number one, my quantity count is going to be wrong. That's something we got to remember. Then of course the bottom line is cost is also impacted, and there is something that I'm going to discuss later on, which is called the cost of quality. That's something that also has a pretty big impact if I have poor quality. Responsibility of quality, you can read this. It actually says responsibility is spread all around. Top management, obviously, they are in charge of things. They are the ones who call the shots. Designers in the company, people who manage technology, they are the ones who should also be concerned with quality. Procurement people, people who purchase parts and labor for us, people who manage contracts for us, those are the people, they should also be concerned about quality. And clearly production operations people and inspectors, their prime job is basically quality. Then quality assurance people, these are the people who take preventive actions. They certainly have a very big role to play in the management of quality, and they are definitely going to be responsible for this. Then packaging and shipping people, that also can be pretty vital. When the package is opened, suppose there is some damage and so on, that's also going to be important. Marketing and sales people, they are our ears and eyes. As far as my business is concerned, marketing and sales people, they have the direct contact with the customer. They are the ones who have got direct contact with customers, and they are the ones who have to make sure that they really carry back some messages for me. And I'm going to repeat this again as we go into this. There's going to be one issue which is like finding the requirements. That's one of the key jobs of marketing people and sales people. Finding the requirements. They should also make sure that they set up a system whereby they are able to register complaints. So there are two reasons why I should be talking to customers. The first is I have to find out their requirements. And the second one is, do they have any complaints? Is there something they're complaining about my process or my product? These two together are pretty strong reasons why I should be talking to customers. And the best way to do that is to have marketing people and sales people involved with them. Of course, I must say this at this point, many times production people or purchasing people, they know nothing about our real customers. That also is not so good. Once in a while, you should expose your people who are in the back rooms, like production people, the factory people and so on, to the real customers. So the fellow who drives the motorcycle on the road and the fellow who is assembling the various different parts, who is assembling the engine, at some point in time the user and the engine builder, they should come in contact with each other, because then the engine builder will know, well, here's a customer who is going to be using my product, he is going to be much more sensitized if he comes face to face with this customer. Then of course the story does not end here. Customer service and after sales, these are also vital as far as responsibility for quality assurance is concerned. That is also there. If you look at the total experience today, whether it's a car or anything else, there's a product component, then with that there's a service component also. When we purchase something today, when we purchase this PC was purchased from a shop. But what we have to remember is, it's not just I was happy just unpacking the PC and getting it started. What if I have some problem with it? Is there going to be a service provided with this? If it is not provided, probably I'll look at some other brand of PC where service is also pretty good. So not only I want to see the good product, I also have to make sure along with the good product I also get good service. And this is true for automotive. There are a couple of slides here you can see. I look at performance, I look at aesthetics, I look at special services, I look at safety, then I look at reliability, I look at deliverability and durability and perceived quality and service after sales. All these different things I look at, and there's always a product component and there's a service component with any of these. This pretty well completes the first part of what I wanted to tell you about getting on with Six Sigma. We'll be moving pretty soon into how do we control that, and I'll be starting with this slide here, which is a system that is now taking various inputs and trying to convert all of that into an output that I can sell in the marketplace. Thank you very much.